Okay folks, sorry for the little hiccup there. We're back and rocking and rolling here. So we have a city council with 9 members, must elect a 4-person committee. How many committees are possible? So the real thing here, notice we can't have repeats on our members, so we aren't talking just multiplication principle, we're talking either permutation or combination. So let's take a look. Let's say there's 4 people, and let's say it's Abe, Becky, Charlize, and DeWitt. Okay, so is that going to be any different than if we selected in the order DeWitt, Charlize, Abe, and Becky? Well, notice these would be the same committee, right? Because it's the same 4 people on the committee. There's no rank or anything like that. So that means this is a combination. So with that in mind, and we'll actually write out, you have 9 people, you want to select 4. So the way we can actually go about doing this, going a little bit quicker now, take that permutation, 9 with 4, and then we divide by that 4 factorial. So notice we can write this as 9 times 8 times 7 times 6, which is basically our multiplication principle if we just did that, and divide by that extra 4 factorial because that's the number of arrangements that we can have of 4 people. Okay, so with that in mind, we can try and simplify this as best we can. So you can actually plug it into a calculator if you want right away, or you can try and do the crossing out method. Some of you struggle with this, you said, so I wanted to try and do that. Notice 3 times 2 and the denominator makes 6. So that'll cross off with a 6 up in the numerator. Now I'll go to pink for this next one. Okay, 8 and 4, they divide each other. They both have a common factor of 4. So we can cross off this 4, and 8 now becomes 2. So that means we have 9 times 2 times 7, and I don't know much, but I think I can handle that one. So this becomes 18 times 7, which is about 126. Okay? And that would be our final answer. 126 let me write it, committees. Okay, so moving on to our next one, let's see if we can distinguish what this is. An alpaca farm is giving away 11 alpacas while you have room for only 3 alpacas. How many different families of alpacas can you make? So in this case, we're having 3 as our final selection, and notice you can't have repeats, right? You're not having, this isn't cloning or anything like that. So we're talking 3 different alpacas as our possibilities. With that in mind, let's say we had Al the alpaca, Brandy the alpaca, and then Candy the alpaca, right? So if we chose those as our alpacas, is that going to be any different than us bringing home Brandy, Al, and Candy in that order? No, this is the same alpaca family. So what that tells us is, if this is the same family, then order is not important. So that tells us this is a combination. Now, what's our set? Well, we have 11 alpacas as our set, and then we want to try and figure out from there what is the number of alpacas we want to choose for our family. Well, it's going to be 3. Okay, so with that in mind, what do we get? Well, we get, once again, the permutation, 11 and 3, and then divide by that last number, so 3 factorial. So that permutation that we just talked about, that's 11 times 10 times 9, those are our 3 numbers multiplied, and we can get that from the multiplication principle. And then 3 factorial, let me rewrite that another way, 3 times 2 times 1. So notice the 3 goes into the 9, and that leaves us with 3 up top. Okay. The next common factor that we can look at is 10 and 2, right? So 2 goes into 10 evenly, and that leaves us with a 5. So this is essentially 11 times 5 times 3, or 11 times 15, which should be 165, I believe. Oh, and then 165, I should write alpaca families. Okay. So now, making the transition into probability, let's see how this works. So we have the meteorologist reports that there is a 70% chance of rain on Sunday. What is the probability of rain on Sunday if the meteorologist's percent chance is correct? So assuming they're giving us the right weather report. Well, this is where people people can work that work the problem out. What is the probability? So probability of rain. Well, that should equal, remember this has to be a number between 0 and 1 for probability. So 70% is our probability. So this would be 0.7 is our probability there. Now on top of this, and this would be our final answer for that, there's not much to this one. But what we can start to ask, and this is where most people get upset with a meteorologist, when they say 70% chance of rain, what does that mean? Well, we can do probability of it not raining. So that becomes 1 minus, there's a probability rule, and it goes 1 minus the opposite event. That'd be 1 minus the probability of rain. So this would be 1 minus 0.7, and so that equals 0.3. So what weather people could end up saying is that, hey, there's a 30% chance of it not raining on Sunday. So keep that in mind. I mean, when you're hearing a meteorologist report, just because it's not what they say is going to happen, there's always a percent chance involved with that. So certain weather patterns, when you hear 50% chance, 1 out of every 2 days it's going to do that, but it means the other day it's not. So just keep that in mind when you're hearing those weather reports. Now, moving to probability, here's one. The reason why I like to bring up this forward and back kind of situation where we use this event not occurring, is because people will try and skew statistics, and the way they say things can actually impact how people view what's actually happening. So the doctor explains that your upcoming surgery has an 80% survival rate. What is the probability you will not survive the surgery? So most people say, oh, 80%, that sounds great. So let me put the probability of survival. What does that equal? Well, we know that equals 0.8, right? So then we want to say, okay, what is the probability that you will not survive? So probability of not surviving the surgery. So from our probability rules, what we can do is we can go 1 minus the probability of surviving, right? And the probability of surviving was 0.8. So notice that makes a 0.2 or 20% chance of, so the probability is 0.2, but that means there's a 20% chance of you not surviving. So that means 1 out of every 5 times you're going to have someone pass away from that surgery. That might be a surgery we'd want to avoid in most cases if it's an elective surgery of some kind. Okay, so keep those things in mind, the way things are phrased. You might hear a doctor say 80% chance survival rate or a 20% chance of passing. That sounds a little bit more risky, right? So keep an eye. There's always 2 sides to that coin is what's going on here. And that's what the probability rule is stating. And so if you have, in general, the probability of not E, where E is some event, that's 1 minus the probability of E. Always keep that in mind. So you have 2 sides to that coin. Okay. So now, what is the probability of purchasing the winning ticket from a lottery where 6 balls are chosen from a bin of balls numbered 1 through 70? Oh boy. So now we talked about lotteries already, right? So so when we do this probability of winning ticket, we're taking the number of winning tickets divided by the total number of tickets. This is the probability of winning the lotto. Okay, so keeping that in mind, what's actually happening here? Well, how many winning tickets are there? Well, if there's 6 balls, you have to get all 6 correct. So there's only actually 1 winning lottery ticket. Doesn't mean multiple people can't choose that winning lottery ticket, but only 1 winning lottery ticket. So now, the fun part, what's the total number of tickets, right? Well, remember we said order is not important on that number of lotto balls. So that means we have a combination going on here, and you have 70 balls, and we want to select 6 of those 70. Now we can calculate that a little bit better, so we can do this combination of 70 and 6. So that should equal our permutation divided by 6 factorial. And what does that give us? Well, this would be, we got to write out 6 numbers. 70 times, oops, that should be a 69 times a 68 times a 67 times a 66 times a 65, all divided by 6 times 5 times 4 times 3 times 2 times 1. Okay. Now we can try and simplify this, or you can just plug it into the calculator. At the end of the day, what do we get? Well, I think we're going to get 131,115,985. So your probability of winning the lotto is 1 over 131,115,985. Now, just to give you a little bit further perspective, and so numbers, well, let's give you how many zeros we have here. 1, 2, 3, 4, 5, 6, 7, 8, and then you have a 7 and a 6 pop up. So keep that in mind. Your odds are not good at all of winning the lotto. In fact, your odds of driving down I-95 and actually hitting a stick the size of a marker is actually better than winning the lotto, to be honest with you. So keep that in mind when you're picking your lotto tickets and picking those numbers. So, and I've always made the offer, if someone ever wins the lotto from one of my classes, you can come back, rub it in my face, I'll take it as much as you want. But no one's ever come back and taken me up on that offer just yet. So we'll see, maybe in time. Hopefully it'll happen. Now for our next one, what is the probability of guessing the top 3 finishes in order for a horse finishes in order for a horse race that has 10 horses? So now we have the probability of the top 3 finishers. Correct. So notice if you picked, let's say your horses are Alice, Bob, and Chan, right? Notice that would be different here than Bob, Alice, and Chan, right? That's a different sort of scenario. So these are going to be different in terms of our possibilities. So these are different finishes. We're going to keep that in mind with what's going on here. This is the number of the correct guesses for the finish. No, I shouldn't say number of correct guesses. Let me write it this way. Number of ways to select the correct top 3 finishers. And this would just be the number of ways to select the top 3 finishers. Notice this isn't necessarily correct in the second case. So moving that down, here's how we go about doing this. There's only one way to pick those top 3. So say ABC is how you finish, right? Then it has to be ABC for that to be the winning ticket. Now, it won't always be the case where you have 1 on top, but just seeing a couple scenarios. Now the next one though, notice we have a permutation because order is important. We just talked about those being different finishes. You have a set of 10, and then we want 3 of those. So now notice that what that makes, that's 10 times 9 times 8, right? So that should be 1 in every 720 in this case. And so what that gives us is approximately 0.0014 if I'm going to sig figs. Sig figs stand for significant figures. So, all right, moving forward to our next bit. So now we want to try and get into this difference between linear and exponential growth. You've actually seen it already, and I want to kind of illustrate how you have seen that. So we have Sally Mae invest $20,000 in a 30-year bond earning simple interest, which you've seen before, with an annual interest rate of 4.5%. So how much money will Sally have from this investment in 30 years? So when we do this, if you recall, we had this A is our final amount, and we had this P times 1 plus R times T. Right? That's essentially what we did to figure out our simple investment. So this is the simple investment form or simple interest formula. Now notice here first we get A equals, our P is 20,000 in this case, and we go 1 plus, our R is 0.045. Now I know we can plug in T, but I'm going to leave it as T for now. And what this tells us, we can even multiply the 20,000 on through if we like. So if you multiply 20,000 to both parts, so you got to distribute it. So you get 20,000 plus, and then when we take 20,000 times 0.045, we should get 900. This is called a linear equation. The reason why is the t is just raised to the first power and it's multiplied by some other constant. Okay, so our formula is A equals 20,000 plus 900t. So when you were doing these before, you were just dealing with the linear equation. We just didn't name it a linear equation. So for our amount after 30 years, we would get A equals 20,000 plus 900 times 30. All right, and so that should be what? 900 times 30 should be, add an extra 0, 27,000. So this should be $47,000. Is what we should see. Okay, so well that's hunky-dory. Now taking a look at this, we can use these linear models to try and model other things. It doesn't have to be just money, right? And so linear models, we're just talking some, usually time involved, but something raised to the first power as a variable for our time. So the population of Smallville was 7,000 in 1990, and the town has grown linearly while gaining 350 people per year throughout its history. So I'm going to still write this A equals P plus RT is the idea, what we finished with. Well, we did PRT essentially, but P plus, let's call it some constant times T, where T is time. In our case, what is our starting point? Well, this is 7,000. And notice we're gaining 350 people per year. And so the T is going to be the number of years after 1990. Okay? So if we're at 2,000, notice we go 2,000 minus 1990, that's 10 is our value. So for our answer for this problem, you get 7,000 plus 350 times 10. Notice that makes 3,500. So this whole thing should become 10,000. I don't know why I put that dollar sign. I'm used to money problems. So 10,500 people would be our answer. So, but this is our model, and I'll highlight this with the stars. And so that goes into our next question. When did the first group of people settle in Smallville? So the way we go about solving that, the first group of people, we'd have to figure out what t is, right? And what value are we taking in order to get there. So if we put 0 equal, because that's right before everyone settles there, 0 equals 7,000 plus 350t, we can solve for t. Notice you get negative 350t equals 7,000. So divide both sides by negative 350, so t equals 7,000 over negative 350. Notice there's a negative value. That's going to be important here in just a second. So notice we can cross off, and let me kind of show that here. You can cross off the 0. 35 goes into 70 twice, so this is going to be t equals negative 20. So that means this is years, and I'll put in quotes, after 1990. So that means if it's negative, so 20 years before. $1990. And so this would be 1990 minus 20. We had in 1970 the population 0. So that means the first settlers, if it was population of 0 in 1970, the first settlers came in 1971. Okay? Questions on that? So I know that was kind of tricky. I'm not going to have anything like that, but I just want you to see how we can use linear equations to develop some even deeper thinking into what's going on there. So now, moving forward into the exponential growth. How does this thing work? Well, we've seen these as well, and I'm going to kind of illustrate. We'll make it a little bit simpler of a problem, but we can definitely get there. So Chan invested $10,000 into a CD compounded annually with an annual interest rate of 6%. Determine the amount of money in the CD after 5 years. So this was the compound interest formula. And keep an eye on T. Where does it appear? And this is a special type of compound interest formula. So your formula went P times the quantity 1 plus R over N raised to the NT. Well, in our case, N is equal to 1, and our P is 10,000. So I'm going to leave the T off on the side for just a second. So this is 1 plus 0.06 over 1 raised to the 1 times T. And so notice this becomes A equals 10,000 times 1.06 raised to the T power. Notice that our T is up in an exponent. This is what we call exponential growth. Okay? So we have exponential growth. In general, what's happening here is you have some formula A equals P times, usually we'll denote this by some B raised to the T. That's essentially what exponential growth looks like. Okay? So when we simplify this down, we got 1.06 raised to the T power. Where can we go from here? Well, in our problem we wanted after 5 years, so we take A equals 10,000 times 1.06 raised to the 5th. And so when we do that, raise 1.06 to the 5th and multiply that by 10,000, we should get our answer being $13,382.26. Okay. Keeping all this in mind, what this tells us is actually even more. We had in the problem what the growth rate is. It was given to us right out the gate, but it's 6%. And the way we always get that is we take whatever the number is on the inside and we subtract off 1 from that, because the 1 actually indicates 100%. And so that's where that's coming from. And we can keep this in mind to talk about growth rates of populations and things like that. This is very important in like spreads of viruses and spreads of bacteria and things along those lines. The same ideas apply. But just to try and tie it back into investments, because we're a little more familiar with that, and then you can get into the other stuff. We have Riles invested $7,000 into a CD compounded annually, and the investment grew to $10,000 in 3 years. What is the annual growth rate of the investment? Well, in this case, we still have that compound interest formula. So A equals P times 1 plus, since we're compounding annually, we'll have a R over 1 and then raised to the 1t. But so the way this looks like is this 1 plus RT. Now we know some of that information. Oh, let's put it in here. So we have $10,000 equals 7,000 1 plus R raised to the t is 3 years in this case. So the way we go about doing this is first divide. We want to try and isolate the 1 plus R. So first thing we do is we divide by the 7,000. Okay. So notice we can cross off all those zeros and we're left with 10 over 7 equals 1 plus R cubed. Now how do we get rid of that cube? Well, we can take what's called a cube root, but what your calculator might do a little bit easier is raise both sides. If we do it to one side, we must do it to the other. So since there's a 3, the way to get rid of the 3 is divide by it or multiply by 1/3. So we'll raise it to the 1/3 power. Okay, so what we get here is this 1 plus R. Now it comes to the 1 power, which is just 1 plus R, and this is 10 over 7 to the 1/3 power. Now if you type that in, just to make sure you're doing it correctly, what you should get, make sure the whole 1/3 is in parentheses, you should get something like 1.126 is approximately equal to R there. And so in that case, we can subtract 1 from both sides, and that means our R is approximately 0.126. So that means our R is approximately a 12.6%. So growth rate, annual growth rate I should say, is approximately 12.6%. Now, it might behoove you not to round it when you're doing the next calculation. You can use that number if you want. But what this means, to give you an idea, if we want to answer the next question to find how much is in the CD after 5 years, we can end up plugging this in. So we get A equals P, which is, oh, here, let me write it. P times 1 plus R. I could write R over N, but in this case it's just going to be 1 plus R raised to the T. And so our A equals, we started with 7,000. 1 plus, now it goes 0.126, or as I said, you can leave in the number. I'm actually going to leave in the whole number. Just for kicks, it'll make it easier. It's already in the calculator. And so take that and raise it. Oh, I'm sorry, I put T up there. We want 5 years. So if we raise that to the 5th power and multiply that number by 7,000, that means after 5 years, the total amount in Riles' account will would be $12,864.34. Just showing you the power of compounding in terms of how that works, and along with the growth rates. So when we're talking exponential growth, we're talking about growing at a certain rate, and so versus linear growth is growing at a certain number, where you can just take the difference of the numbers and you'll get that growth rate in the linear case, versus it's a percent increase on all the others. So you can't just take a difference on exponential. So there's a review of modules 7 and 8. If you have any other questions, please don't hesitate to ask. You can post them in the YouTube live review. You can post them in the discussions. I'll be around. You can come ask me. And we'll have one more review coming up for the final as well. So wish you all the best of luck. And if you don't have any other questions, you all have a good day.